When we're talking about Lambda, it is a serverless event-driven mechanism, or in other words, your code is going to be triggered based on some events. Those events can be from state changes of your EC2, or your auto scaling triggering some activities, or somebody uploading some objects into your S3 bucket. Any number of events, Amazon allows you to have a lot of triggers as on today, and all this without managing any infrastructure, without provisioning it, without configuring it. You just upload your code to Amazon Lambda and choose like provisioned IOPS. You just go ahead and say, I want this much memory, and you also say that I want to execute for 3 seconds, 10 seconds, or 1 minute, and Amazon will provision the necessary amount of CPU for you, the hardware for you, and everything. And finally, the other two aspects of Lambda which makes it really interesting is it is completely scalable. The number of events that are coming in will trigger a Lambda. So if you are having one event, in other words, one person uploading one image, it will trigger one Lambda. If 100 people are uploading 10 images, then it will trigger 1,000 Lambdas automatically. So it scales up and down automatically, and you don't have to worry about it. And the background, you are all built for 100 milliseconds. If you remember, EC2 is built for 1 minute at a minimum time and 1 second increments after that. But Lambda is built at 100 milliseconds. So if I go ahead and say I want to run a Lambda for 1 minute, then you have 10 billing cycles available within those 1 minute. And sometimes the code gets completed in 300 milliseconds or 500 milliseconds, and you just get billed for those milliseconds only. And finally, you can write Lambda scripts in quite a lot of programming languages. As on today, Python, Java, .NET, Go, all these four are supported, and they keep adding more and more support. It's difficult for me to keep track, but those are all possible. So this is one of the common use cases for Lambda, where a picture is taken and it is uploaded to S3 bucket, and every single upload of an object will trigger a notification, and that notification will be sent to a Lambda function, and this Lambda function can resize that image or generate thumbnails for your mobile or web application or tablet sizes. And it also can do object recognition also. It can find out who are there, whose faces are there, what is the background image, whether it is Sydney or it is Paris or Delhi, whatever it is, and then it can go ahead and put it in another file saying this object had all this metadata, and in other words, this person had visited these places, things like that. Then you can tag your friends automatically or send a notification saying so and so has gone to Paris. Do you put a like button or something like that? So this is one use case of Lambda. The another use case that I'm going to demonstrate now is using Lambda functions to automatically take snapshots of your backup and clean them up as well after a certain period of time. So for that, I've written some couple of GitHub articles because we need some Python code which will do this for you. I have pre-written those code. So all we are going to do is just copy paste them into our Lambda console, and we'll be up and going. Let me just go ahead and get to my GitHub article now. So in short, if you can see here, this is my GitHub article which explains to you how to use serverless EBS volume snapshots using Lambda functions. There are a couple of prerequisites. We'll go one by one. In short, the flow is something like this. You have 3 servers or 2 servers or whatever servers, and you have some EBS volumes. And every day you can have a cron job which can be triggered by your CloudWatch. And that when the time happens, say night 12 o'clock or every 5 minutes or every 10 minutes, you can trigger a notification to a Lambda function, and Lambda will go ahead and find out what are the volumes are attached to those instances, and then it will take the snapshot and send it to your snapshot storage. So this is the workflow of how it happens. There are a couple of prerequisites. One is we need an EC2 server, obviously, to find out what volumes are attached and to take a backup, and that volumes should have a key called as backup, and it should also have a value called as yes. And here is the code that is given here. So the first thing is EC2 server. Let us go ahead and set that up first. Let us add the key that ensures that Lambda will go ahead and find the instances which are supposed to be taken backup. And if you remember, the key value has to be backup, and the value of that key equal to be S. So I'm just going to add those things here. So here we have our EC2 server coming up and online. and then it is having a tag which allows Lambda to identify that this server wants to be taken backup, and it says a value of yes. What I'm going to do is I'm going to start another server without this tag and see whether Lambda can differentiate and pick up only those servers with this backup and trigger that. So there are two servers now, one with the necessary tag, that is this one, and let me go ahead and select the other one, and if we go to the tag section, the backup tag is not there. So we have met the first prerequisite, and the next prerequisite is setting up a Lambda role. So we know already how to create a role. Let us go ahead and do that quickly if we have not done. So my role is now ready, which is a serverless backup bot, and it allows Lambda functions to call AWS service, in this case EC2 instances. So this is the script which is going to do that magic. And here I would recommend you to go ahead and see what is the deletion days that you want. Say for example, whether you want to delete the backup in 70 days or 10 days automatically, because we creating one more Lambda function which will go ahead and scan all your backup snapshots and find out who are supposed to be deleted today. So leave it as 70 or whatever your management team says it has to be. So I'm just going to copy this for now. Just copy it all the way down here. And let us go back to our EC2 dashboard. I'm just going to duplicate it so we can leave that one alone and configure Lambda now. So services, and under compute Lambda. And let us go ahead and create a function called as create function, and I'm going to call this as serverless backup. And remember, it has to be Python 2.7. I have mentioned this in my article also. Before the code starts, if you see the first line, create an AWS Lambda function, choose Python 2.7. If you are going to choose Python 3, it might work, it might not work, but there are no guarantees. I have not tested it for Python 3. You can see here 3.6 is available on the other different languages that are supported by Amazon. C#, Go, Java, Node, Python, all are there. So choose this one as Python 2.7. And remember, we created the Lambda role. So let us go ahead and choose the existing role itself. And I want to choose the one as serverless backup bot. And click on create function. So it's going to take in all the parameters we set in. It says congratulations. So where do I paste my code? So let me close this one. If you click on this function name that is at the top, serverless backup, it will ask you to go down. You can see here there is a small triangle that says go down, and if you scroll down, here is where you just go ahead and delete the existing one and paste the code that we just copied from the article. And if you scroll down here, and you have these environment variables, if you want to set up or pass some parameters, you can go ahead and pass it on using the environment variables. And the other thing about memory is, if you want to change your memory, how much memory you want to allocate to your Lambda function. Starting is about 128 MB and it goes all the way to 1 gigabyte or 3 gigabytes. So that's quite a lot of CPUs available to you. And how long you want your Lambda function to run, whether I want to run it for 3 seconds, 10 seconds. Let us say I want to run it for about 10 seconds. Okay, I'm sorry, this has to be 0 and this has to be 10. And your execution role is mentioned on the left hand side. Do you want to run it in a secure VPC? For most use cases, running it under no VPC would be fine. And how many Lambdas you want to trigger concurrently. So if you want to set that up, you can go ahead and say, I want to run only 20 Lambdas at the same time. Then you go ahead and say 20. But if you set it at a default limit, you can start at the same time. That is 1000 Lambdas can be triggered every millisecond as the incoming rate of events. So let us go ahead and save. So now we have just configured our Lambda function, but this is not going to get triggered by any means because we have not given set up a trigger mechanism or a cron job. So for that, you can see here, add triggers from the list on the left, and I want it to happen periodically. And CloudWatch events are the ideal way to do that. Go ahead and click on CloudWatch events, and it says configuration required. Click on that again. If you scroll down, the page will change a little bit, and it says video is lagging. Okay, let me do that. Here CloudWatch events, and just if I remove this, CloudWatch events and configuration required, scroll down, And here you have an option to create new rule. Let us go ahead and click on create new rule. So rule name is automate backup, just fine with the same description. And the easiest way I would like to do is you can do a cron job description like that. If you want to go ahead and learn how cron jobs are configured, you can go ahead and find them more about. I'll give you a link later for that, or you can go and Google it. It's typical Unix cron job, but Amazon makes it more easier to say rate one day. So if I do something like this, at UTC time every day once it will be triggered, or I can go ahead and do saying something like this. If I do something like this, rate 2 minutes, it is going to trigger my Lambda function every 2 minutes. So I'm just going to set it as 2 minutes, and then I'm going to click on add. And what is going to happen is my Lambda function is configured with a trigger, and it is not yet enabled. You can see here there are some unsaved changes. If I go ahead and save, my Lambda function will also have a trigger, and that trigger will happen every 2 minutes. Before saving it, I want to open EC2 dashboard, and I want to go to the volumes section and the snapshots as well. So I just duplicated the page, and if I go to volumes, you can see here there are, as of now, there are two root volumes, both of them attached to different servers. You can see here one server is Lambda demo, another one is Lambda do not backup. And under snapshots section, as of now, this one was created by us a few days back. Let us go ahead and delete that. Okay, so there are no snapshots at this moment right now. So I'm going to back to my Lambda function, click on save, and you can see here this is saved. From unsaved changes it has become saved. And if I scroll down under CloudWatch events, you can see here it is under enabled state. So in about 2 minutes I will have my Lambda function triggered and a backup automatically happening. And if I go to monitoring, I should see a spike here when the Lambda function invokes. And if there is any error in any of my configuration and the Lambda triggers and it fails for some reason, I should be seeing a spike in this section, which is called as invocation errors. So let us give a Lambda 2 minutes. There we go. We have our snapshot. We have our Lambda function triggered. You can see here there is a small spike and there is one invocation happened. Let me go to my EC2 dashboard and hit refresh button. And you can see here the Lambda function has triggered, and today is February 4th, and it has calculated about 70 days, and it says that this snapshot will be deleted on April 16th. So if I go to my tags section, you can see here the same tags have been added here, triggered by Lambda demo, and the delete on field has been set to April 16th. And of course, this delete on tag is also completely customizable. If you come to the Lambda function at the top, you can see here the retention tag is here, and I have set it as delete on. And if you want to have it at a different date, you can go ahead and do that. And I have set it as 70 days. So any Lambda function in future which comes and runs it for every day, it will scan for the date. And if the date mentioned here is matching with the current day's date, it will go ahead and delete it. So we can do that Lambda function also quickly. So in case you want to clean your snapshots automatically based on certain tags or dates, there is another function that I have written which is called as a serverless janitor for EBS snapshots. Once again, there are a couple of prerequisites. You need a couple of EBS snapshots with a delete on tag and the date in the format as YYMMTD. Here you can see here my existing snapshots is having the same format YYMM and TD. And the next prerequisite is having a Lambda role with EC2 full access, and we can also use inline with the more restrictive, but for a demo, let us go ahead and with the existing Lambda serverless bot role. And the necessary function is given here, and here I have given the delete on tag as the one that is automatically configured, and then the retention date is 7 days, but that was currently 70 days, so you can go ahead and change it anytime. So I'm just going to copy this code once again. Let us create a new function for our janitor backup. So I'm just going to call as serverless janitor for EBS, And again, Python 2.7, let us use an existing role as serverless backup patrol, create function. And once again, click on the function name to update the code. If you click on it, it will ask you to scroll down. If you scroll down, this is the part where you need to update the code. Just going to paste it here, and I'm just going to click on save. So my function is saved now. Once again, I don't have any triggers for my backup. We are going to do almost the same way we just now did. What I'm going to do is I'm going to choose CloudWatch events, click on configuration, scroll down, and put in a rule. We can use the same rule, automatic backup, because it just all it does is it's going to trigger for every 2 minutes. So we don't have to set up a new rule, but if you want, you can just go ahead and set it up also. CleanUp backup every 2 minutes, something like that. I'm just going to write it here. Same description. And I'm going to use the same format because it's quite easy for me to write it in that format, and I can trigger it immediately every 2 minutes. And click on add. And once again, it's going to come back and say these changes are not saved. So let us go ahead and save it. So it is saved now. If I go to my monitoring section, and let me refresh once again, there are no invocations at this moment in the invocation count, and in 2 minutes it is going to invoke and say that nothing has happened, because it is going to, what this script is going to do is it is going to see, are there any snapshots that are going to be deleted today? That is it matching today's date? Then it is going to delete it. But if we go to our EC2 dashboard, if I see our snapshots, all of them have a delete on date of April 16th. So none of those snapshots are going to get deleted. If I want any of them to be deleted, it has to match today's date. So I'm just going to rename one of them. I'm going to say just will be deleted so that we'll see this disappearing. Will be deleted because this name tag has no meaning. But if I go ahead and edit this delete on date to today's date, today is, what was today's date? I'm just going to check what is the UTC date they have given here. Okay, February 4th. I'm just going to say the same thing. February 4th. And okay. Okay, DDYYMMDD, correct? So this is going to be number 2. So that's the date, right? February 5th. Okay. So this snapshot will be deleted when my Lambda function triggers. So let's just go ahead and wait for our Lambda function to trigger. Where is my Lambda? Here it is. Let me go to monitoring and go ahead and hit refresh. Okay, it has triggered once. Maybe the change will not be picked up immediately. Maybe it did, but let us wait for one more trigger to happen. There you go. You see here when the Lambda triggered the second time, it wiped out the disk which had a delete on date as today. So that is how you configure both Lambdas for monitoring your servers, taking a backup and setting the delete on tag that is in something in the future, and another Lambda which will come back and clean it automatically, saying snapshots which are older than 70 days will be automatically cleaned up. So you don't have to come and do. Think of it something like the lifecycle policies that we do in S3 buckets.